Hello, so welcome to a video on thread safety. This program is based on the classic programming problem, the Dining Philosophers simulation. So up here we have our necessary libraries that we're going to need for this program. And then using namespace std is a preference. So first off, we're going to start with our number of philosophers that we want. So I chose 5 philosophers. And next we're going to do a vector of mutexes representing the forks, ensuring that only one philosopher can hold a particular fork at any given time. And so we decided to start at 50% hunger. And then here we have our variables. Here's a mutex for controlling access to the hunger levels, our mutex for controlling access to the print function. Here's going to be our first function here, and this is going to print the current status of either them thinking or eating, as well as their hunger level. Basically, right here is what's going on is that it's going to ensure only one thread prints at a time by locking the print mutex variable. And then here we have our cout statement, and that's going to give us the current status. Next, we have our function to modify the hunger levels. So here, we're going to do another lock guard, and this is going to lock the hunger mutex variable to modify hunger levels in a thread-safe manner. And this basically here is just going to update the hunger level by adding the delta, but it's going to clamp the value between 0 and 100. And then our next function here is going to retrieve the current hunger level in a thread-safe manner as well. And basically, again, we're going to lock our hunger mutex to safely access the hunger levels. And then we're going to return the variable. And then our next function here, it's going to represent the philosopher's behavior. So we got a little bit going on here. This is going to be our while loop, and we want to make a while loop to simulate their infinite life cycle. And so basically, they're going to have their hunger increase first by 20. They're going to be thinking first, and then this is going to print their new hunger level here after thinking. We're also going to simulate a 2-second pause so it's more readable, the output's more readable. And then here, this is how we calculate the fork indices, because each philosopher has a left and right fork. Basically, why we're using modulo here is because it's going to wrap around the indices for the last philosopher, so the forks are arranged in a circle, because that's what we want. And then here we have an if statement, which is preventing deadlock by picking up the lower numbered fork first. Then we have a swap here to make sure it always picks the lower number. And next, we lock our forks, so we can simulate them picking it up. And then here we have the philosopher eating, which is going to reduce the hunger by 40. And then we print our status of the new hunger level. Again, we're going to simulate another 2-second pause. We put down our forks again to allow other philosophers to pick them up. And then another small pause. Then we have our int main function. Basically what's happening here is we have a vector to hold all the philosophers' threads. And then we're going to create a thread for each philosopher by having a for loop. And then here, this is basically just keeping the program alive by waiting for the first philosopher thread. Now we're going to run the program.